Talk about the cosine rule. Interchangeably, you'll see this a lot as the cosine law, whether it's a law or a rule, whatever it is, you're using this to find out some extra things about triangles that we haven't really done yet before. So if you look at the traditional labeled triangle that we always look at with sides A, B, and C, well, you always know that the opposite angle from a side is going to be the larger capital letter. So here A is across from length A, C, big C is across from little c, and then the angle B is across from the little b, right? So knowing about this is really going to help you when you set these things up. So what the cosine rule does is it gives you a relationship between three sides. So you have three sides and one angle usually is what the cosine rule is talking about. Right? So in general, the regular cosine law looks something like this, where it's a squared is equal to b squared plus c squared minus 2bc cos of a. And just for consistency here, I'm going to make that capital A, because that means that we're talking about the cos of the angle A, right? So angle A here. The one thing that might trip you up over this process is there's a couple of different ways to write this, right? So of course, like our sine law, we can write it a couple of different ways. Same with area of a triangle. So here we can also write b squared is equal to a squared plus c squared minus 2ac cos of b. And again, you could write it as c squared is equal to b squared plus a squared minus 2 ba cos of c. And so really the number one thing that you need to notice about all of these when we're trying to find lengths is that this a, or whatever's in front, is going to be the angle that we're going to be using. So we're going to be using the length in the opposite angle side is what we use the cosine of that angle, right? So here are just two lengths, so we use the lengths in the middle here and here, okay? So any one of these will work, and as soon as you get a triangle given to you, you can label it so that way it always finds the A value. But if you know that you're just finding a length, you have to use the opposite angle in order for it to work out using the cosine rule. So just one thing to kind of remember if you're looking for a quick cheat on those types of things. So what do we use the cosine rule for? So if we want to look at a specific example here, so I'm going to give myself some more space. And let's say that I have this angle, a triangle that looks something like this. I have this length on the left over here is 10 meters. This thing down below is going to be 12 meters. And inside here I have a 38-degree angle. And I have the pinwheel of death, so I hope that doesn't stick around. Okay, there we go. So I have a 38-degree angle on the inside here. And I can label this any different way that I want to, so I can call this A over here or B over here, but for the sake of simplicity, I'm going to stick with this first formula that we have, so I'm going to solve for an A. So let's call this angle A, let's call this length A, let's call this angle B, therefore this is going to be length B, and this is going to be big C over here, and that means that this is going to be little c over here in brackets. Alright, so just setting this up as it is, notice here that this is the contained angle bit that we talked about in the area of a triangle, so an angle sandwich. So if you can identify that you have two lengths and an angle in between, and you have to find the other length, most often it's going to be a cosine rule question. So if you have something that looks like it could be either an area of a triangle or it could be cosine rule, then you're looking at finding a length using cosine. So filling in the blanks here, we know that A is going to be our unknown, so we'll keep it on the left. A squared is equal to, and my B was 12 squared, and I have my C as well, so that was 10 squared. And I have to add, that's minus 2 of, minus 2 times 12 times 10, right? And times the cos of 38 degrees, okay? So here, this is a really simple one. You just have to plug and chug and go through the process. So we'll say that a squared is equal to 144 plus 100 minus 2 times 12 is 24 times 10 is 240 cos of 38. Unfortunately, my calculator on my computer isn't really working right now. I'm trying to get a quick fix for the next video, but what we would do if you had your TI-84 is you'd plug all that in, or you could take the square root of that all at once, so it could look something like this in your calculator, where you take the square root of everything, put that underneath, plus 100 minus 240 cos of 38. One thing to be aware of here is that when we're multiplying that cos 38 times 240, you got to make sure that you're multiplying these two together and not saying minus 240 and then plus cos 48. So that's a thing you might get tripped up on. So after the calculation, and if you'd like to see how you do that on your calculator, just ask me in class. It works out that this length over here, this length A, is actually going to be 7.41 meters, right? So we're dealing with meters, and this one right here turns out to be 7.41 meters. All right, so that gives us an idea of how to find a length using the cosine rule. So there's a lot of moving parts here. There's a lot of bits and pieces. So there's a lot of 3 lengths, and then you use 2 of the lengths again, and you have your extra angle. But really, it's just putting things in the right spot and being really careful with the math. So make sure you don't skip over any step too quickly. If you're one who really isn't so good at doing mental math, maybe working on that or using your calculator. Most cosine questions would be like a paper 2 type of question where you're going to get some approximate answer for a solution. All right, so moving on now to finding angles, right? So before we were finding lengths, now we're going to talk about finding angles using the cosine rule, okay? Now, there is a bit of a way to rearrange the last formula that we saw. I'm going to leave that up as an exercise for you to kind of show your understanding. So if you can algebraically work this old formula out, so if you can work this out to show using triangles what our next formula would look like for finding angles, do that now. It's actually a good exercise. But just to kind of take away the mystery here, it's going to be cos of A is equal to B squared plus C squared minus A squared all over, and it's 2BC. Now, again, there's multiple ways to write this. So either you label the triangles the way you want, or you can kind of look at them like this. We say cos of B is equal to A squared plus C squared minus B squared all over 2AC. Or finally, if we have cos of C is equal to A squared plus B squared minus C squared all over 2AB. So if you can notice the pattern here, we're always taking the cos of the angle and we're subtracting the length on the other side. So see here how I'm subtracting this length, and the other 2 lengths are the ones that are being added. And after that, if I look below, the only 2 things that I'm dividing by is 2 and then the 2 first lengths. So 2 in the first lengths here, 2 in the first 2 lengths here, and then again the same with the bottom ones. So we're always subtracting the length that's opposite of the angle we're interested in. So B, see how we're subtracting that other side for B squared, and C, we're subtracting that other side from the C bit, okay? So you can either remember that, we're always looking for the opposite length to subtract, or you can kind of remember each of these set up. Depending on how you learn, you would kind of understand that the best, okay? So if we were to kind of doodle out an example here, let's say that I have another triangle that looks something like this, right? And I have something with 11 centimeters, and over here is 14 centimeters, and on the bottom is 12 centimeters. So if you're given a triangle that has 3 lengths and no angles, it's going to be pretty obvious to you that this is a cosine question. Because there's no angles. And the cool thing about this is you can figure out any single one of these. Once you figure out one of them, maybe you could use the sine rule to figure out another. And then again, you could use the 180 degrees minus the other two angles to figure out the third one. So if you're giving 3 lengths, before we might have scratched our heads, but now we certainly know how to figure out how to get every single piece of this puzzle now. Okay, so that could be a good exercise for you. And I think that's in question 3 in our textbook on page 269 if you want to practice that as well. So if we're looking at this, let's say that I'm looking at angle C, right? So I'm interested in this C down here, meaning that I'm going to have to label this little c, and arbitrarily I can say this is A or B, and I might as well just call this A, meaning that this is going to be length A, and this will be B, also known across from it as length B. Okay, so we have all of our lengths all labeled, which is really good if you're just starting off with these things. So here I know that I'm looking for C, so I'll say cos of C. Now remember, I use the other two that are really the contained angled bits, so A and B, so I'll say 14 squared plus 12 squared minus 11 squared. So it's the opposite side is that C squared bit that I'm subtracting from, so 11 squared up here. And this will give me, on the bottom, 2 times 14 times 12. All right, so now if you just look at this, this is all pretty straightforward. You see all these things. There's no rearranging or anything like that. Although in a couple of steps, there is going to be one thing to look at in regards to taking the negative c of this, or the negative cosine. Okay, so let's simplify this a little bit. Cos of c is equal to 196, so that's just 14 squared. 196 plus 144 minus 121. 121 all over 2 times 14. 2 times 14 is 28, and 28 times 12 will give me 336, right? So 336. I'll add all those on the top together, and I'll get a total of 219 all over 336. Now, a lot like our right angle triangle questions, we have to use the inverse sign here for cos. So in order for me to figure this out, I have to say that the angle C is equal to cos to the negative 1 of this ratio of this fraction right here that I have, so 219 over 336. And that'll give me a nice angle here of 49.3 degrees. Now again, if you need some help figuring out how to do that in your calculator, please ask me in class. But here, so now we know that this is 49.3 degrees. All right, so now that we know this angle, we can use the sine rule to figure out what either one of these two are, and then we could figure the other angle out by knowing that all 3 angles must add up to be 180. So really, this kind of concludes everything that we need to know about triangle dimensions, right? So we know how to take the area, we know how to take the sine law, we know how to use the cosine law. So all of these things now, we're pretty squared up when it comes to triangles. We're able to figure out just about anything. So when you come to class on Friday, just come down, sit down, and get some practice in.